Welcome to Chapter 9 review. We're going to, for those of you that would like to see some examples written out or need some help with this assignment just to make sure that you feel a little bit more confident before we go into our test, we're going to do the review. So this is Chapter 9 review, and we're going to walk through this together. And again, if you want to stop and pause this to the tape, you can. If you want to fast forward to because there's sections that you understand how to do, feel free to do so. Make sure that you show your work along the way, even if you don't have the video on. So let's begin. We are on the Chapter 9 review, and we are on page 466. 466. And we're going to begin with number 1. And it says to copy and complete the statements. And so we're not going to copy the entire sentence down, but we are going to copy down a little bit of it just so we kind of keep track of what our question is. So let's begin. Number 1, what are vertical angles? And so we are just going to copy down that word, vertical angles, for a moment. And you can stop the video and pause and take a look and look up vertical angles either on your note cards or in your book. But in the meantime, we're going to draw vertical angles. And vertical angles are when two lines intersect. They don't have to be perpendicular at 90 degrees, just as long as they intersect. And they are opposite of each other. So for example, if I labeled these angles 1, 2, 3, and 4, we would say that vertical angles, they are angle 1 and angle 3. They're opposite of each other. So to answer our question, what is a vertical angle? A vertical angle are when two lines intersect, they're angles that are opposite of each other. Another example, of course, would be angle 2 and angle 4 are also vertical. Angle 2 and angle 4. But to answer our question, angles that are opposite of each other are what are vertical angles. Skip a line. Number 2, are all rectangles parallelograms? Well, let's draw a picture of a rectangle. A rectangle has 4 right angles, and it could look like this too, which we also would call a square. So it says, are all rectangles parallelograms? And you have to have the drawing. Parallelograms have two sets of parallel sides. So it are equal to 2 sets of parallel sides. And so we take a look. Both the rectangle and the square, which is also a rectangle because it has 4 right angles, are both parallelograms. They both have 2 sets of parallel sides. So the answer to this question is yes. Now, if you just put the answer yes down, I'm not going to give you credit for it. You need to show how you came upon that answer. That's the exchange for not copying down the question. Number 3, how many acute angles does an acute triangle have? So let's draw an acute triangle. An acute triangle could look like this. Acute triangle could look like this. But acute triangles are triangles that have all acute angles. Well, this one here probably is not an acute triangle. That's an obtuse triangle. We can't use that one. So acute angles are all less than 90. Acute means is equal to less than 90 degrees. So if they're all less than 90 degrees, are all acute. How many acute angles does an acute triangle have? Well, 1, 2, and 3. So answer is 3 angles. Number 4, how many obtuse angles does an obtuse triangle have? So let's draw an obtuse triangle. An obtuse triangle is more than 90 degrees. And we can make it sit like this. There's lots of ways to draw our triangle. But they are more than 90 obtuse is equal to more than 90 degrees. And so if we take a look at our two drawings that we have, how many obtuse triangle angles does an obtuse triangle have? Well, in both cases we can only have one, because the other two are acute. So only one. And box that in. Number 5, what is the relationship between two supplementary angles? So we have to draw an example of supplementary angles. So we have a straight angle, and supplementary angles are two angles that equal 180 degrees. So this is supplementary angles. So in this case, if this was equal to 120 degrees, this angle would have to be equal to 60 degrees. So the sum of their measurements, supplementary angles, and we have two angles that equal 180 degrees, and that's our answer. Let's go on to number 6. Number 6 is an angle with a measurement of 100 degrees is an example of what kind of an angle. So if we have an angle with a measurement of 100 degrees, which is a little bit more than a right angle, so if we say an angle and this is 100 degrees, what kind of a angle is that? And so our choices are acute, which means less than 90, obtuse, which is more than 90, or right, which is exactly 90. So in this case, what kind of an angle is that? It's more than 90, so it's an obtuse angle. Box it in. Number 7, a straight angle has a measurement of how many degrees? Well, let's draw a picture of a straight angle, which is equal to 180 degrees, which is equal to 180 degrees. Kind of just gave you that answer right there. Number 8, two figures are blank if they have the same size and same shape. So if we have two figures, whether it be a triangle, same size, same shape, or if we have two rectangles, it doesn't matter what the shapes are, and they have the same size and same shape, we want to say they are congruent, is how we would describe them. Same size, same shape, congruent. Number 9, we have a regular polygon, has how many sides, lengths, and blank angle measures. So I'm going to write this one out. A regular polygon has blank side lengths and blank angle measures. So if we have a regular polygon, and it doesn't matter what kind of polygon it is, it could be a quadrilateral, same sides, same angles. It could be a triangle, 3 sides, 3 angles, and they're all the same. And we could have a regular polygon. A regular pentagon would have 5 sides that are same sides, same length of sides, same angles. So when we have a regular polygon, it means that all the sides are the same and all the angles are the same. So whether it's a triangle, a quadrilateral, a pentagon, if it has a regular polygon, all the sides have equal sides and they all have equal angles. Number 10. Let's go down to our drawing. We're going to use that diagram on page 466 to help us with our answers. It says use the diagram of a gate to name the following. So this is kind of like one of those portable gates you might put up in a doorway in case you have pets that you don't want to go into a certain room of the house. So let's take a look. We want to name 3 points. So 3 different points on that gate. There's actually 4, 6, 7 of them, but we just want to name 3. So I'm going to say point S would be a point. Point T, and make sure your letters are all capital. We could say point R. Those are all points. Now there's many more examples as well, but you only have to list 3. Number 11, we want a horizontal line that goes through point V. A horizontal line that goes through point V. Horizontal means across, like the horizon, and it has to go through point V. So a line, and again I'm making this kind of too long, I'll just make it short. So a little line, and it has to have V. So V, line VW. We could say line WV, it'd be the same thing. We could say line VR. We could say line RV. Those would also all be correct. It has to be horizontal. So if you have one that goes to VP, that would not be correct because it's not horizontal. So one of these have to be one of your choices. Number 12, a segment that has R as an endpoint. So a line segment that has R as an endpoint. Doesn't matter which direction, doesn't say. So we could say R, line segment RT. We could say line segment TR, could be in that order. We could say line segment RW. We could say line segment QR. It doesn't say doesn't have to be in any order, but there's lots and lots of choices of R being an endpoint. Number 13, a line that's parallel to the line in exercise 11. So whatever you put down for number 11, one of your choices for number 11, a line that is parallel. So parallel goes, they don't cross. So if we picked line VW, a line that goes parallel would be line ST. Or line, you could write it like this, line TS, either one is fine. Or you could have, that would probably be the choices. Number 14, we have name the angle in 3 ways and what is its vertex. So here's our drawing of our angle right now. We have this angle drawing, and it's angle JKL. Make sure you use all caps. Name the angle in 3 ways, and then what is its vertex. So 3 ways, we can say angle K, we can say angle JKL, that K has to be in the middle, angle LKJ are the 3 ways that we can name that angle. And another question is, what is the vertex? The vertex is equal to K. So there's the answer to the 2 questions for number 14. Now we're only almost to the end of the time on this video, and but let's go on number 15. Actually, number 15 is this. Let's take a look at let's do it on the same page. The one that we drew for number 14, let's take a look at that, and let's estimate what our, I have to make the rays a little bit longer, but I'm going to estimate what I think that angle is. And I'm going to say about maybe 50 degrees. That's my estimate. I'm just guessing. I know it's an acute angle, so my estimate's equal to 50 degrees. I'm going to measure this now, and I see that my angle is equal to about 52, 53 degrees. The actual is equal to 53 degrees. So I've actually measured it, and I can label it too, 53.